Alrighty, this is our video on graphing quadratic functions. Today we're going to graph quadratic functions that are written in standard quadratic form, whether it looks like the y equals this form or f of x equals this form. But before we go any further, I want to remind you that we already know how to graph quadratic functions that are in this form right here. If you remember, this right here is what the very basic y equals x squared looks like. Well, for this function, right here, this x minus 4 tells us that the vertex of the standard parabola is going to be moved 4 units to the right, to the right, and then 5 units up. So that would be the vertex. And if this 3 wasn't here, then we would just have the standard y equals x squared from there. But it's not there. But there is a 3 there, so that means it's going to be a little bit thinner, or it's going to change quicker because of this 3 right here. But that's something we've already done before. So today we're not going to work on functions that look like this. We're going to work on ones that look like this, the standard quadratic form. But if I simplified this, I would get that. So these are the exact same thing. So notice the standard vertex of 0, 0 has been moved 1 to the right and 3 up, giving us the vertex of 1, 3. Since this is positive, it is opening up. And because there's a 2 there, instead of it being just y equals x squared, it's a little bit narrow because of the greater rate of change. Also remember that every parabola has an axis of symmetry, and that goes right through the vertex. So the equation for that line is x equals 1. Everything for the rest of the parabola is symmetric around that axis of symmetry. The key to be able to work the problems that we're going to have today is to know that the equation for the axis of symmetry is going to be x equals the opposite of b over 2a, the b and the a. The c does not affect the axis of symmetry because that only moves it up or down. It does not move it side to side. Okay, so here's my first equation to try. So again, I must figure out the axis of symmetry and then therefore the vertex. Remember, the equation for the axis of symmetry is x equals the opposite of b over 2a. So in this case, it's the opposite of 4 over 2 times 2. I believe this equals negative 1. So x equals negative 1. Therefore, the line x equals negative 1 will be our axis of symmetry, and the vertex must be along there somewhere. So let's figure out the y coordinate of our vertex. All we have to do is take the x coordinate of negative 1 and plug it into that equation. So negative 1 squared is
1 times 2 is 2, plus 4 times negative 1 is negative 4. This equals negative 2. Negative 2 minus 5 equals negative 7.
Therefore, my vertex is negative 1, negative 7. So I'll go ahead and graph that. Negative 1, negative 7. That's my vertex. And also my axis of symmetry goes right through there. Next, all I have to do is find a couple of more points. And one of the easiest points to find is the y-intercept, where this parabola is going to cross the y-axis. Well, remember, if it's going to be on the y-axis, then the x-coordinate must be 0. Any point on the y-axis, the x-coordinate is 0. So let's look at the equation. Let's let x be 0. Basically, that's going to make this disappear, and we're going to see that y equals negative 5. So the y-intercept is 0, negative 5, right here. So I've got my vertex, I've got the y-intercept. Let's find one more point. I'm going to go ahead and stick to the same side of the axis of symmetry. So I'm going to try for x being equal to 1. Let's see what happens. So we're going to go plug in the 1, and 1 squared is 1, times 2 is 2, plus 4 times 1 is 4, minus 5, that'd be 6 minus 5, that equals 1. So my next point is 1, 1. Okay? And I think we're pretty safe from there. Keeping in mind the axis of symmetry, we can find our twin points. Okay? This is 1 point to the right of the axis of symmetry, so I'm going to go 1 point to the left. This is, I'm sorry, 2 spaces to the right of the axis of symmetry, so I'm going to go 2 spaces back to the axis of symmetry. And now I can simply graph my U-shaped parabola. And I am done with this one. Next example, you'll notice that this is standard form, but the BX part is missing. That makes this pretty easy. I pretty much know that my axis of symmetry is going to be the y-axis, and that the vertex is going to be at 0, 3. This is the vertex. Now that happens to also be the y-intercept, so that's not going to be one of my other points because I already have that. So now I'm going to have to find a couple other points. Let's just stick with the right side of the axis of symmetry. So I'll go with x being equal to 1. So let's see, when x is 1, 1 squared is 1, times 2 is 2, 2 plus 3 is 5, so the point 1, 5 is one of the points. Let's go with x is equal to 2. 2 squared is 4, 4 times 2 is 8, 8 plus 3 is 11, so my point is 2, 11. That takes me slightly off the graph, but I'll be okay. There's that point. Again, keeping in mind that the axis of symmetry for this one is the y-axis. If I'm 1 space to the right, I go 1 space to the left, 2 spaces to the right, 2 spaces to the left. I think I have enough to be able to graph my parabola, my U-shaped parabola. And there we go. I would say a very nice job.
Hello?
And next example. So let me figure out the axis of symmetry. The equation will be x equals the opposite of b, which is negative 8, over 2a, a being 1, 2 times 1 is 2. This looks like a positive 4 for me. So the axis of symmetry is x equals positive 4. My vertex is somewhere on there. Well, let's figure out what my y-coordinate on there. So let's plug the 4 in here. 4 squared is 16, minus 8 times 4, that's 32. 16 minus 32 is negative 32. And then minus 9, that's going to be a negative 41. Of course, I was just testing you there. 16 minus 32 is negative 16, and negative 16 minus 9 is negative 25. So my vertex is at 4, negative 25. Unfortunately, this won't fit on this graph, so I'm going to have to change some of those numbers there. So I'm going to go by 5, so I'll just put a 10 here.
20, 30, 40, etc.
Okay, so I would also make the change on the y-axis. I'm just not going to do that at this time. So my vertex is 4, negative 25. So here's the 5. So 4 is going to be a little bit in front of it. And then negative 25, 5, 10, 15, 20, 25. That would be 4, negative 25. Now I'm going to go ahead and look for a couple more points. I'll just stick to the right of that vertex. So let's let x be equal to 10. Well, 10 squared is 100.
Minus 8 times 10 is 80, that would be 20. And then 20 minus 9 is equal to
11. So my next point is 10, 11. 10, 5, 10, and then 11. That's my next point. Okay, next I would have tried x equals 20, but that got me something too big. It wouldn't fit on the screen. So I went ahead and went with x equals 12, and I got y equals 39. So I'm going to graph 12, 39. 12 would be right here. 39 would be at 5, 10, 15.
30, 35, 40, 45, 39, sorry. 5, 10, 20, 25, 30, 35, 39 would be about right.
There. And now I have enough information for my parabola after I do my twin points. So 10 is to the 6 to the right, so I'm going to go 6 to the left of the vertex. That'll bring me over here. And then 12 is 8 to the right, so I'm going to go F8 to the left of the vertex. Right there. And now I have enough to graph my parabola. Job well done. Okay, And for this next equation, first thing I'm going to do is rewrite this in standard quadratic form. So y equals negative 4x squared plus 16. Again, I'm missing the bx part in the middle, so I think this makes life easy. Therefore, I know that my vertex is going to be at 0, 16. Looks like I'm going to have to go by 2's here. So let's pretend like I changed these numbers here. We'll go by 2's. And so the 16 will be right here on top of the 8. Also notice that since this is a negative number, my parabola is going to be opening down instead of opening up. Okay, that vertex also happens to be my y-intercept, so normally I would go with the y-intercept, but I can't here. So we'll go ahead and find two other points. Let's just go with x equals 1. 1 squared is 1 times negative 4 is negative 4. Negative 4 plus 16 equals 12. So one of my points is 1, 12. Then I'll go with x equals 2.
2 squared is 4, times negative 4 is negative 16, plus 16 is 0. So we're going to graph those points. 1, 12. Remember, 1's going to be here, and then 12, we're going by 2's. And then 2, 0, 2 would be here, and then 0. And I do my points of symmetry, would be right there, and right there. So now I have enough points to do
my parabola. Next example, let's find the vertex. X is equal to the opposite of b over 2a. 2 times negative 3 is negative 6. So this is going to be equal to a positive 1. So let's figure out our y. When x equals 1, 1
squared is 1, times negative 3 is negative 3. Negative 3 plus 6 is 3, plus 5 is 8.
So my vertex is 1, 8. Okay. That vertex is not on the y-axis, so I'm going to go ahead and find out the y-intercept for this parabola. And remember, when it's on the y-axis, x equals 0. So if I let these x's be 0, we pretty much get that y equals 5. So that would be my y-intercept. Okay. Let's go ahead and find one more point, and we'll stick on the same side of the vertex. So I'll go with negative 1. I'll plug in the negative
1. Negative 1 squared is 1, times negative 3 is negative 3, plus we'll get negative 6, that's a negative 9. Negative 9 plus 5 is negative 4, so we have negative 1.
Negative 4 is my other point. And then we'll go with the points of symmetry. 1 back, so 1 over. 2 back, so 2 over. And now I can graph my parabola.
You're almost there.
Okay, last example. The axis of symmetry will be the opposite of b, which is negative 9.
Over 2a, which would be 6, would be a positive 9, 6, also known as
3 halves, or 1 1/2. When I plug that in, I get for y negative 1.75, so I'm going to go ahead and graph that point. 1 1/2, and then negative 1 3/4, right about there. That would be my vertex.
What? What? What?
Just like before, to find the y-intercept of the parabola, I'm going to let x be 0, so this all goes away. So I'll see that y equals 5. That would be my y-intercept. And I'm going to go ahead and go with one more point. Okay, I went ahead and did some calculating. When I plugged in negative 1, because I wanted to stay on the same side, I got that y is equal to 17, which wouldn't fit on here. So I decided to go another route. I went ahead and let x be equal to 2, and I got negative 1. So the point 2, negative 1 is on my parabola. So now I have to be pretty careful about how things are symmetric. This point right here is 1 1/2 to the right of the axis of symmetry, so I'm going to go 1/2 back. This point is 1 1/2 to the left of the axis of symmetry, so I'm going to go 1 1/2 to the right, and that will give me this point right here. And now I can go ahead and graph my parabola. And say goodbye.